function, which is something like this one, right? So y is let's say a sine kx, right, plus phi, right? Or let me write it as not kx but omega t plus phi, right?
Yes,
So this you must have seen in something.
yes,
Now,
I have seen.
yeah. So if I ask you that what would be the differentiation of this thing, so what is the rule that we are going to apply?
So first, it's like the chain rule.
Yes. So again, we'll apply the chain rule. So in here, A is a constant, right? So it will always be outside. So we take the differentiation of this whole thing. So what would be the differentiation of this thing?
Sin x will be cos x,
So that would
and
be
then
cos
and then
omega
we'll write
t.
it, yeah,
And then
and
d
then
by dt of
omega t.
plus 5, right? So this
Hmm.
part would be 0.
Hmm.
Then differentiation of omega t. So omega is outside dt by dt, that is 1. So that would be only omega, right?
Hmm.
So this is what you get. A omega cos omega t plus 5, right? So this
Yes.
you have seen in SHM. Whenever we have an SHM, so the force is directly proportional to minus x. And if we write this thing, so this is a double dot, right? Or if we write it as F, so this is minus kx. And this F is mass into acceleration. So this is minus kx. Acceleration in terms of distance. So that is the second order differentiation, right? So I can write it as mx double dot. In here, x dot is dx by dt. X
Hmm.
double dot is d square x by dt square, right? Double differentiation. So this is the equation that we get. And if we solve this equation, so the solution is a sine omega t plus phi. Or we can also write it as a cos omega t plus phi. Both are correct, right? Okay, so yeah, this SHM at some point we will move, right? This SHM kind of question we have done. Right? So now let's say that we have this kind of question. So let's say the question is y is, let's say, sec, or let me write it as sine 4 sine cube x plus not x, but let's say 4 sine cube and let's say x square plus 3x. Right. So how many functions are there in this question?
One.
One. Because if there is only,
Like, what do you mean by function? Like,
yeah, function of function. So how many function of function? How many individual functions are there in this question?
two.
Okay, so what are those two?
X square and 3x.
So I'm asking about types of function, right? Sine is a trigonometric function. X square plus
Oh.
3x is an algebraic equation. So you have three functions, right?
Hmm.
First one is this one, algebraic. Second one is this one, that is trigonometric. And then the last one, that is again algebraic,
Okay.
right? So first, let me just simply, we will come to this question later, but let's say that, yeah, first we do this question, y equals to 4 sine cube x. So now you have only two functions. One is algebraic,
Yeah.
and then the second is trigonometric.
Trigonometry.
Right. So if we do the differentiation of this thing, what we'll get first? 4 is again out. What would be the
12,
difference?
4
Oh,
into 3 times
yeah. 3 sine square x, yes. And
and then
then
we differentiate sine, which will become cos.
cos, right? So this would be, as you were saying, 12, and then yeah, sine square x and cos x, right? So this would be the answer. But now if we talk about this differentiation, so what would be this one?
It will be 12 sine square x.
Okay. So directly, this is 12 sine square and x square plus,
3x. And then we're gonna differentiate sine, so we will cos, and then x square plus 3x.
and then
And then
in,
it will become 2x into uh, 3x.
2x plus 3, right?
Yeah, 3.
So this is the final. So good. So now I guess your differentiation is very strong. So now we can move on to the integration part, right? Yes. So now the next part is integration, right? And what is the meaning of integration?
R.
Adding up, right? So this is adding up. And what is the physical meaning we will learn now. So let me just see this here and then. So integration meaning adding, right? So let's say in differentiation, we divided some, let's say x into, let's say we have this x, right? This is some x. And if we take a very small portion, so this is what we call dx, right? So this is dx, this is dx, this is dx. So if I sum all these dx, right, all these dx. So there is a simple notation of these summation, and that is what we write. Let's say x equals to dx from, let's say, or let me write it as yeah. So let's say I equals to 1 to n and then dx I, right? Or I can write it in a continuous form, and this is what we call integration, right? So if n becomes infinity, and then this is 1 to infinity, then this becomes integration of dx. So can you tell me that if I sum all these dx, what I will get? If I sum all these dx, then what will I get?
X.
X, right? So if I completely sum it up, so then it will be x. Good. Now, what is the meaning of this thing? Because in the differentiation, we have this operator, right? This is differentiation. Okay, give me a moment. There is a call.
Okay.
Okay, so this was the differentiation operator, right? And then we operated this on some function, let's say y. So we operate this thing on some function y, so this becomes d by dx of y. Similarly, we have this operator, and then we have to operate it on some function. So we operate it, and this is the independent quantity, right? So this is the notation of integration. And this means what? So this means that summing y or adding y all dx. Right. So this is what we mean by integration. But what is the physical meaning of this thing, right? So what is the physical meaning of this thing? So let's say that we have this x variable, this is y. And let's say that this is my y, right? So what I do is that, let's say I take this part is dx, right? So this part, is what? This area would be what? This is up to, let's say this is some point y. So this is y dx, right? Is it clear? Is it clear? And then this part would also be some, this is again dx. And then this is again, this area would be y, right? So if I add up all these y dx, then what I will get? What I will get?
Add like those 2 points.
Yes, I will get what? Your voice is not clear. So we'll get this whole thing, right? From here to here, we'll get this whole area, right? Is it clear?
Yes.
So this is the meaning, geometrical meaning of integration. So the integration of some quantity, and let's say that this would be some fixed quantity. So let's say this would be some x1, and this would be some x2 one, right? So I can put some limits also. So let's say that this is some x1, this is some x2. So this would give me area under y between x1 and x2. So that is the meaning of integration. Is this part clear to you? Is this thing clear?
Yes, sir.
Yeah, so the physical meaning of differentiation is tangent, right? So if I have this function, right? So differentiation at this point means tangent, right? Tangent is dy by dx, and integration. Let's say this is some function. So integration is the area under this curve. So that is integration, right?
Okay.
So these are the two physical meaning of differentiation and integration. Now we have some known results of integration, right? So known results, what are those known results? So first one is the algebraic, right? So what would be the integration of xn? So integration of xn, and we are talking about whenever you don't have any limit. So this would be called indefinite integral. Right? Because we don't have any limit. And then let's say if I put some limit, let's say if I say x1 to x2 and then y dx. So this is definite integral, right? So we'll talk about this thing later, but let us understand the known results first. Right? So we integrate this thing x n dx, and this integration would be xn plus 1 divided by n. So this is integration of algebraic function. Let's say we have a trigonometric function, let's say sine x. Or let's say we have cos x. So then this integration, so this thing would be opposite. In differentiation, this was cos x, and cos x was minus sin x, but in here this would be minus cos x, right? And this one would be, so yeah. So this would be minus plus signs, not minus, right? So integration is opposite, and we can understand that. Let's say if you have some function, right, which is dy by dx. So in every operation, right? Let's say you have some y, which is 6 into 3, right? So this is in multiplication. If I take it in the left hand side, so what would be the this form? What would be this operation?
Division.
So this would be by 3, right? Similarly, if I take this thing the other side, so then y would be integration of fx dx, right?
Okay.
So this integration is reciprocal operation of differentiation, right? So if you take differentiation to other side, it would become integration. If you take integration the other side, it will become differentiation. So that is the idea. Clear?
Okay.
Yeah, so similarly, you can understand that if I have d sine x by dx, that is cos x, right?
Yes.
So if I take this thing the other side, right? If I take this operation, this is the operation, right? So that would be what? In the right hand side, it would become what?
It will become integration of cos x.
Cos x d. So that is how
Yeah.
we get the integration of cos x as sin x. Similarly, if we have d by dx of cos x, so that is minus sin x, right? So if we take this thing the other side, so cos x will be integration of minus, or I can write sin x dx, and this minus I can take it in, right?
Hmm.
So this is how we get those two results, right? But integration, yeah, this one is very tough thing, right? So now we have this algebraic function, trigonometric function, and one more function that if we integrate 1 by x dx, right? So this would be, can you apply the algebraic formula here? Because what is this power?
1 by 2.
No, power is what? So this is 1 by x. If I take it in the numerator, so this would be x minus 1, right?
Oh, yeah.
And if you integrate
Simple.
using, yeah, if you integrate it using using the what we call the algebraic formula, what you will get? Try to integrate from the algebraic one, what you will get?
You get x 1 minus 1 plus 1 will be cancelled, and then
Yeah.
so we'll get x.
Right.
Yeah.
But you have numerator which is 0. So this is 1.
Hmm.
Denominator is 0. Something
Oh,
divided by 0. So that is indefinite, right?
yeah.
So we cannot apply algebraic rule, right? For this function.
Okay.
But we have a known result of differentiation, right? If you remember that differentiation of ln x, this was how much? This was 1 by x, right? So if we take this operation,
The side will be integration.
yeah, so
of
this
the
would
log
be integration of dx, right?
Hmm.
So integration of 1 by x dx is ln. Clear? Or we
Okay.
can write it as log x, right? So both are correct. That's but it is yeah, usually written in log x. Okay. Yeah. So now the last one is the most difficult. So integration of, if we have a function which is ex, exponential function. So integration of exponential function, this is simply ex, right? So
Yeah.
this one is very useful. So these are the known results, right? You note it down, and then we'll talk about the rules for integration, and then we'll do some questions. So please note it down.
I've wrote this all the time. I just want to write
Oh,
the last page.
last thing. Okay, yeah. So then
Yeah.
please. Oh, you were simultaneously noting it down.
I like to note it down like while they're like teaching.
So then you will lose concentration, right? Because if you are hearing and then you are also writing, so you are doing two things simultaneously, right? Our mind is not that strong to handle two things simultaneously, right? So
I don't know, when I write it down, I understand it.
oh yeah, that one because yeah, so that's what happens in revision. In revision, you write all those things again. So in that way, you can. But yeah, that is if whatever you are comfortable with, so that is okay. Yeah, whenever you have noted, please tell me. Yeah. Yeah, and you can try this thing on your own. So you can try this action and you can understand that our mind cannot handle two things simultaneously, right? So you make a circle from your toes, right? From your toes of your feet, and then you try to make a circle from your hand. So you can try that and you won't be able. So from your feet, from your two of your feet, you make a circle and simultaneously you make a circle in here, right? So this thing you won't be able to do that. You can try that, right?
There's
So
like another way trying
yes,
to their fingers in like different directions simultaneously, like it's
yeah,
a circle, but they will not.
yeah, yes, that's yes, good, yes, good observation because our right feet is connected with our left brain, right? Or and then our right hand is connected with so oh both are connected with our left brain only, right? So with the left brain, we are trying to send the signal to our hand and at the same time to our feet, right? So then it would be, that's why it's, yeah, it's very difficult. Okay, so yeah, maybe your biology teacher can explain it more
I'm not a
elaborately, right? Oh, you don't have biology.
yeah, I'm math student.
Oh, you have maths. Okay, so
Yeah,
then, but you can ask in your school, there would be some biology teacher, right? So you can ask. Right? Okay, so what we were doing, yeah. Now let us understand the rules of integration. There are many lots of rules for integration, but we will require only those which we need for our purposes, right? There are lots of rules because different integration is a comparatively tough one. Differentiation only had those six rules, and we can apply those rules anywhere. But this integration is a tough one to handle, right? So yeah, that's why there are lots of rules. But we'll only study those which we require for our purpose. Okay, so the first rule again, the same one, that yeah, if we have, let's say this dx, or let's say if we have dy, or if we have, let's say, whatever, let's say dt. So all these integration, because we are summing up all those x together, right? All those small x. So this will be x, this will be y, this will be t. So that is a very important, right? Clear? Yes, is it clear?
yes, sir.
Okay, and then if you have, let's say the second rule is that if a constant is multiplied with some function, right? And then you integrate it with this dx. Then you take out this k, and then you can integrate this, right? So this is the same one as the differentiation. And then you have, yes, do you have any question?
Saying yes.
Okay. And then the third one is that if you have u plus v dx, then we can separately integrate both the functions, right? The same one as this one. But we don't have a multiplication rule, right? There is a multiplication rule, but that we don't have to study, right? So if we have two product of two function, and then you want to integrate it out, so you have to take out one, right? And then integrate the second. And then in the next one, you have to take the differentiation of this part and do the integration of second. So this one is yeah. So this you won't require. Have you studied this thing now?
No.
Yeah. So this you won't require for our purposes, right? Or we can yeah. So multiplication is not needed. Division, we can't do division in integration, and we can't apply chain rule in integration, right? So you can imagine that simply doing this integration. So we don't have any chain rule to do this integration, right? Differentiation was easy. If we have this thing, so we can apply chain rule, right? But this we cannot apply, right? So yeah, this is the limitations of the integration. So that is why this, yes,
So question, like if you have to solve
if you have to solve which one?
the sine square x.
Yeah, this one. So then we have to use something in which we know how to handle, how we can change this thing to the known results, right? So in this case, we know that let's say that if I have this integration sine 3x plus 4 dx, right? So this one is a linear. So what we can do is that we can put 3x plus 4 as t, right? Now, if we differentiate this thing, so if I differentiate this thing, so this would be dx, and this constant would be 0, and this is dt. Is it clear?
Yes.
So I can find out that dx is dt by 3, right? So then with the substitution method, I can solve this thing. Now, what would be the integration? If I put this thing, so what would be the integration then?
Sine will be minus cos.
No. First, I have put this thing. So we cannot do that. What we did from the earlier cases, right? So we cannot apply chain rule, right?
Oh,
So
okay.
yeah. So first we put this thing, right? So what would be this integration? Then if we write it in form of this thing, what would be this integration?
So replace x plus 4 by t.
So this would be sine t, right? And then dx, I can write as dt by 3. Now this thing is a constant. So 1 by 3 is outside, and then sine t dt. Now this one is a familiar one, right? So then I can write this integration as minus cos t, right?
Okay.
And then I can put the value of t. What was t?
T was 3x plus
So this is how I can do this problem. Right.
4. Okay.
Yeah. But yeah, if you have, let's say, if you have, yeah, if you have sine and 3x squared plus 4, right? And integration is x sine 3x squared plus 4 dx. Can you integrate this thing and tell me what is the answer you are getting? Try to integrate this thing. But before you do that, please note down this, right? So, yeah, please note down something. So we only have 3 rules, right? Multiplication is not there, division is not there, and chain rule is not there. We cannot apply those things simply in integration. So the important rule in this integration is substitution, right? That is the important.
So can you scroll down?
Yes, yes, sure. And whenever you have completed this question, please try this. Please try this one, right? So yeah, please
Okay.
try this. So you see that there is a product, right? X into this function. So it will seem that it is a very difficult one, right? And we have to apply the product rule. But yeah, if you think about this question carefully, then it will become simple. So yeah, think
So
about this.
I replaced dx
Yes,
by dt by 6.
GT by 6. So you have to, yeah, you have to take 3x squared plus 4 as
T.
t. Then
And then
this
we're
would be
gonna
6x dx. That would be dt.
yeah.
Right. So x dx you can put as dt by 6, right?
Okay.
So this thing sine this thing is sine t, and then x dx, this becomes dt by
dt
6.
by 6.
So you see that how simpler this integration becomes. This is simply 1 by 6 minus cos t. So this is 1 by 6 and cos 3x square plus so this is the integration, right? And there is what yeah, so there is a product rule that is there, right? And what is the product rule? So it says that if you want to integrate, there are two functions, 1 and 2, right? So
Yes.
you take out the first integration and then the integration of the second. Oh, so okay, then this will become a very lengthy one, right? And then you subtract it with the differentiation of 1 and then you integrate the second one, right? So this one is a very complicated one, so yeah, we should leave it there. Right. So okay, so up to this point, is it clear?
Yes, sir.
Okay, now yeah, as you were asking that how we can integrate this sine square. So to integrate that sine square, the idea we have to use is trigonometry, and then of course integration, right? So that is also. So what I can do is that I know that cos 2 theta, right? This is cos square theta minus sine square theta, or this is 2 cos square theta minus 1, or this is 1 minus 2 sine square theta, right?
Yes, sir.
So in place of theta, I can write x everywhere. So this is cos 2x, cos square x minus sine square x, cos square x minus and sine square x. Now, if you look at all these functions, so I want to integrate sine square x. So which relation I can use? Can you tell me?
The last one.
The last one, right? Good. So I can write sine square x as 1 minus cos 2x by 2, right?
Yes.
Now this integration becomes easy. So now if I put, because the question is sine square x. So I can put this as 1 minus cos 2x by 2 dx. Now cos 2x I can integrate, right? So this would become the first rule, or the what was third rule, 1 by 2 dx and cos 2x by 2 dx, right? So this integration half is taken outside, integration of dx, half is taken outside, integration of cos 2x dx. So integration of dx is how much?
X.
X. So this is x by 2 minus half, and then cos 2x. So I put 2x equals to t. So this would become dx 2 equals to dt. So dx is dt by 2, right? So this integration, let me just tell you that whenever you have some coefficient multiplied in this one, so you just divide this thing, right? Or let's say that what would be this integration? So this is cos t dt by 2. So this would be 1 by 2 minus not minus, because cos is positive, right? So this is sine t, right? So this would be sine 2x by 2. So just remember that whenever you have some coefficient multiply with this variable, in integration, we just divide it. In differentiation, we multiply, right? So you can check this. So this would be sine 2x by 2, right? So this integration will be x by 2 minus sine 2x by 4. So that is the integration of sine square x dx. Is it clear?
Yes, sir.
Okay, now we have talked about this thing. So now we can talk about that what is the definite integral, right? So if I ask you that, or let me just say that we have a integral, right? And let's say this is some function x square dx. Now I want to integrate this thing in some limits. So x1 is the lower limit. From where I want to integrate. And x2 is the upper limit up to which point I want to integrate. Right?
Hmm.
Because if we don't have any limit, then that would be, so let's say if you have some function, right? This function is going like this, and it has this way and this direction. If I don't put any limit, x1 and x2, then I won't get any answer, right? This would be indefinite. Where is this point? Where is this point? So I have to put some limit into the integration, right?
Hmm.
So if I put some limit, then this would be x cubed by 3. And I have, let's say I take x1 to be 1 and then this to be 2. So I am integrating this thing from, let's say, 1 to 2. Right, this is 1, this is 2. So x1 is 1, x2 is 2. From here to here, I'm integrating this thing. Right. So the upper limit is here, this is the lower limit. Now this 3 is constant, so it will be outside. And I have x square as function. So in definite integration, first I put the upper limit. So if I put the upper limit, what would be the function? Here the function is x square. In place of x, I have to put 2 first.
Hmm.
And yeah, so this would be 2 square, right?
Hmm.
And then subtract it with the lower limit. So 1 square. So this would be 1 by 3, 4 minus 1. So this is 3 by 3. So this would be 1. So this would, yeah. Whenever you have a definite integral, then you will get a definite number. Right. So if I didn't add any limits, then it would simply be x squared dx would be simply x cubed by 3. So this can be anything. This answer is not definite. But whenever I
Okay.
put some limit, then it becomes a definite answer. Right. So that is the difference between the definite integral and indefinite integral. So note down this thing and then I will give you one question. Okay, so Mariam asked us about this basic thing, right? And she's not around. What will
Yeah.
happen in the next class?
So can you scroll up? I have to write that question. I did not write this one.
Which this one?
Yeah.
These are okay. What I will do is that we'll keep this class for 1 hour only, right?
Okay.
And because if I in the next because the next thing that I have to start is vectors. And if I start that and she's not here, then it would be difficult to, then I have to take another class again, right? So yeah, whenever you have noted it down, just
Yes, sir. Please scroll down. Sir, I'm done.
yeah. Okay, so yeah, so in the previous example, right, let's say if we have some limits, right? So let's say we have again cos square x and dx, and this is from 0 to, let's say, pi by 2, right? So this is the integration that we have. So what would be this integration, right? Oh, why did I write 2 times dx? So again, what I will do is that I will write this thing as 1 plus cos 2x by 2, right? Because I'll have to use the second thing. So cos square or cos 2x is 2 cos square x minus 1.